So good morning all. Continuing with the unit number 6, that is template. In today's session, we are going to learn about generics in C++. Then we are going to learn about generic functions, generic classes, followed by the power of templates. Already almost all these things we have already covered, but again I have arranged this session to know more about generics in C++, generic functions and generic classes, and you should understand the advantages and disadvantages of the template so that you can use that template in efficient way. So followed by the question answer session. So this is the agenda of today's session. Begin with the generics in C++. So generics is the idea to allow type. Keep in mind, type is nothing but the data type like integer, string, float, double, etc. and user defined types to be parameter to method, classes and interface. So again I am repeating, generics is the idea to allow type to be a parameter to the method, classes and interfaces. For example, classes like an array, map, etc. which can be used using generics very efficiently. The classes like array and map is used very efficiently in generics. We can use them for any type. Irrespective of data type, you can use these classes and you can play with any type of data with these classes. That's why the name given as generics. The method of generic programming is implemented to increase the efficiency of the code. Generic programming enables the programmer to write a general algorithm which will work with all data types. It eliminates the need to create different algorithms if the data type is an integer, string, or a character. So generic programming is implemented to increase the efficiency of the code. Within less code or minimized code, you can implement or you can perform the different tasks. So this enables the programmer to write a general algorithm which will work with all data types. And it eliminates the need to create different algorithms if the data type is an integer, string, or character. You can have one generic algorithm to all kind of data types. So let's see the advantages of generic programming. So first is code reusability. Once you write a particular algorithm, no need to write the same algorithm for different kind of data type. Same algorithm is used for different types of or different kind of data types. That is one of the advantage of generic programming is code reusability. Next is avoid function overloading. With the help of generic programming, you can avoid the function overloading. Once written, it can be used for multiple types and cases. Once you have a particular algorithm, you can use it for in multiple times and at multiple cases. So these are the advantages of generic programming. So how to perform the generics in C++ or how to implement the generics in C++? We can implement generics in C++ using the templates. With the help of templates, we can implement the generics in C++. And already we have learned this about the templates. Templates is a simple and yet very powerful tool in C++. The simple idea is to pass data type as a parameter so that we don't need to write the same code for different data types. As I already said, you need to have one simple algorithm that is called as generic algorithm, and which will help to complete your task or based on different data types. No need to write the same algorithm for different types of data types. For example, a software company may need a sort method for different data types. Rather than writing and maintaining the multiple codes, that is multiple sort method, we can write one sort method and pass the data type as a parameter. That's it. Only one sort method will help you to perform the sort operation on string, integer, float, character, etc. So let's begin with the generic functions. Generic functions using template. We can write generic function that can be used for different data types. Example of function templates are sort, max, mean, print array, etc. So this is the simple code which will show you the generic function. We are going to include the IO stream and we are going to use the namespace std. And this one function works for all data types. And this could even work for user defined data types. So template, type name T, and T, here it is T mymax. This is the method T x comma ty, where this T is a data type. And then whether x and y is greater than x is greater than y or not. If it is so, it will return x. If it is not, it will return y. You are familiar with this ternary operator. This is the simple function template. This function template we are going to use in our code. Our main, integer main, out mymax integer 3,7. So this mymax method will be called over here, which is of function template, and we have passed this 3 and 7 as a integer. Now this max will call this template method, and it will return the greater value among x and y. So it will return the value 7, and output of this is 7. Next statement, say out mymax double 3.0 comma 3.7. So this statement again call this max function template. Here it is 3.0 and 7.0 is assigned to x and y of type T, and it will return the greater value between 3 and 7. So it will return 7.0. Call next using the character mymax. Again same method will be called. This method will be called, and here it is we are passing g and e. In this case, it will return the greater value among e and g. So it will return g. So in the same code, we have called the method mymax, and we have written the template of mymax over here. and we have called this method with integer, we have called this method with double, we have called this method with character. No need to write separate methods for this type of data type. Only one method is, one function template is essential. This is the output of the code 77 and G, which is already I have written over here. So now you can understand what is the importance of function template. One function is used at this place, same function is used at this place, and same function is used at this place. No need to write the separate methods. So there is code reusability. That's why the benefit of template is, one of the benefit is code reusability. So let's begin with the generic classes. We already covered this. Still again I am repeating this so that we will be clear in this template and generic concept. So generic class using the template. Like function templates, class templates are useful when a class defines something that is independent of the data type. Can be useful for classes like linked list, binary tree, stack, queue, and array. So this is mostly used for this kind of classes: linked list, binary tree, stack, queue, and array. Following is a simple example of template array class. So let's begin with the example. We have included iostream using namespace std, and this is our template class. This is the syntax of the template class. Template, and this is the type name T, class array. So we have used this array class over here. Inside we have a pointer of type T, integer size, and in the public we have method array, that is the constructor, and we have method print, void print. Now this is our template, and now we are going to write the code for this array and this method print. So let's begin with the array code. Template type name T and array T colon array T of array and integer s. It will receive a character array and size of the array at integer s variable. So ptr is equal to new T s. Okay, so one pointer array is created. It is initialized to this ptr, and s is initialized to size. Now in the constructor itself, we have iterated over the array. Ptr I is equal to array I. We have initialized this ptr I with the value of array I. So where my one array is initialized to the ptr, and this is the task of the constructor. Now let's begin with the print method. Template type name T, void array T colon semicolon print. So for integer I is equal to 0, I less than size and I plus plus, say out value at ptr plus I. So every time it will get incremented and it will print the values of array. Here it is end of the print method. This is the end of the print method. Now in we have created this array. Integer array 5 is equal to 1, 2, 3, 4, 5. And here it is, we have initialized this array integer, and we have passed this A, created object A, and we have passed this array over here. Array A and size is this array we have passed over here, and this is the size 5 we have passed to as a size. At this stage it is received over here and it will get initialized over here. Then next is when we call a.print, at this stage this print method will get called. And simply the task of print method is to print the values present in the array. So it will print the values 1, 2, 3, 4, 5. So this is the output of the code. And this is how you can create the class template and you can use it in your code. You can create array of any type of data type. Here it is, we have created the array of integer. You can create the array of float, array of double, array of character, array of objects, and so on. So this is called as class template, generic class. Let's begin with the power of templates, advantages of the templates. The first advantage is C++ templates enable you to define a family of functions or classes that can operate on different types of information. So one of the advantage of template is to allow to define family of functions or classes that can operate on different types of information. It uses templates in situations that results in duplication of the same code for multiple types. For example, you can use function templates to create a set of functions that apply the same algorithm to different data types. Next is you can also use the class template to develop a set of type-safe classes. Again, this is one of the advantage of template. Templates are sometimes a better solution than C micros and void pointers. Instead of using the C micros, you can use the templates. And they're especially useful when working with the collections and smart pointers. These are advanced topics, so we can learn it more about this. Template classes are more type-safe and could be preferred over runtime resolved code structure, such as abstract classes. Often, the main reason to use the templates in combination with STL, and it can drastically reduce development time. You can now understand what does this mean by drastically reduce the development time. Within a fraction of, or one method is useful for multiple situations. So it will reduce the development time. So let's see the disadvantages or limitations of the template. Historically, some compilers exhibit poor support for templates. That is the compatibility of the compilers. So the use of templates could decrease the code portability. Many compilers lack clear instructions when they detect a template definition error, and this can increase the effort of developing templates and has prompted the development of concepts for possible inclusion in the future C++ standard. Since the compiler generates additional code for each template type, indiscriminate use of template can lead to code bloat. Bloat means the code is generated behind the scene which is not useful. More code is generated, that is called as code bloat, resulting in larger executables. Because a template by its nature exposes its implementation, injurious use in large systems can lead to longer build time. Because of this, you can have longer building time. It can be difficult to debug the code that is developed using templates. Since the compiler replaces the templates, it becomes difficult for the debugger to locate the code at runtime. Templates are in the headers, which require a complete rebuild of all project pieces when changes are made. So no information hiding, all code is exposed exposed in the header file. So this is one of the limitation of the template. As in when you use template in more situations, we can understand the limitation as well as advantages of the template. You need to be friendly with the templates so that you will get the clear ideas